We're asked to find the integral from 4 to negative 6 of 5 f of x dx. We're given a couple pieces of information. One from negative 6 to negative 2 f of x dx equals negative 3, and then from negative 6 to negative 4, the integral from f of x dx is 2. Now, I see something in common. I see that one of these integrals, and I'll point it out here, this one has bounds of negative 6 and 4, and this one has bounds of 4 and negative 6. I see that they're flipped. We can remember the reversal of limits rule tells us that if we have one integral with certain bounds, if we flip the bounds, then we get a negative version of the integral, because instead of going to the right, we're going to the left, we're going backwards. And so, if I want to find the integral from 4 to negative 6, that'll be the same as finding the negative integral from negative 6 to 4. So I'm going to write that out. We want to find the integral from 4 to negative 6 of 5 f of x dx. And we know that's going to be the same as the negative integral from negative 6 to 4, because again, we're just flipping, and we keep everything else the same. Now, what else could I substitute? Because right now, I still don't see just integral of f of x, I see integral of 5 times f of x. There's another rule that we can apply, and I'll highlight this one, or mark this one in red, where we have a constant. Remember that if there's a constant being multiplied by our function, or if we just factor something out, we can factor out that constant, and that constant alone. And so here, I can say that this will equal negative 5, because I'm taking that 5 outside of the integral. I'm factoring it out from negative 6 to 4 of f of x dx. And now, what do we see? The integral from negative 6 to 4 of f of x dx, that's exactly what I'm seeing here. And what does that equal? That equals 2. And so we can substitute that. This will equal negative 5 times 2. And so in the end, we see that the integral from 4 to negative 6 of 5 f of x dx will equal negative 10.